Today, we are going to hear from Dr. Simon Pickard, who is a professor in the Department of Pharmacy, Systems, Outcomes, and Policy, and also the Director of Graduate Studies within the department. Simon got his bachelor's in pharmacy from the University of Alberta, and also his PhD from the University of Alberta. He subsequently relocated to Chicago and hasn't left since, which was, almost 20 years ago?
Almost 2001.
Yeah, almost 20 years ago. So he clearly is now a native of Chicago. He even holds Bears season tickets. So if you want to talk to him about the Bears, you can feel free to do that. He's going to talk to us today about his work in. He's also, I should mention, he's also been a longtime member and the head of the executive group, the chair of the executive group for the Uruqual Group. And he's going to talk about his work in valuing health in the U.S. using the EQ5D.
Thank you very much, Todd. Welcome, everyone. Some of you have not attended the seminar before. I want to welcome you. And just so that you know, this is a graduate student seminar. And this study itself, presentation is targeted at kind of a introductory graduate level, so we're not going to get into some really technical elements, but when Todd approached me about doing a seminar, he said, every 2 years, try to get the faculty doing a seminar, and I was thinking about it, what I should talk about, and one of the things that occurred to me was it'd be nice to kind of do a reflection on kind of a narrative around a whole body of research that I've been doing in terms of measuring and valuing health outcomes. But then it occurred to me that I hadn't actually presented for the faculty and students on this major study that we undertook that was based at UIC, but it was also international in nature. And the story behind it goes back quite a few years. And so it's very satisfying to get to the point where we have our revised manuscript resubmitted as of this week, and hopefully there'll be some good news about that. So this is the background behind developing a value set for the EQ5D-5L. How many of you have heard of the EQ5D? And how many of you have not? Okay, so there's a couple of you that I'll take a brief amount of time to introduce you to the measure, but the EQ5D is one of the established measures for measuring the quality part of a QALY. And so I just want to talk to a bit of the background to this study and the role of the EQ5D in health economics and as an outcome of health. Outcome measure for health. And then we'll talk a bit about this study and the results and how to use this value set that has been derived. I just need to acknowledge not everyone on this slide, but it's enough to say that this was an initiative that was international in nature. There was a lot of people who assisted us with it. A lot of different academics from around the world. There's also some PharmD students that are even still here. Ashley, Michelle. We've got graduate students that were involved. Rachel, Chris, Connie. So you guys, you haven't seen this presentation, have you yet? No? Okay, good. So this will give you some closure to what you did in the summer of 2017, and what a fantastic research team we had. So there was also a stakeholder advisory group that is a bit different. We often don't have an advisory group for research projects of this nature, but given the potential scope for hopefully the impact of the work, and that we used and disseminated to a lot of different stakeholders. We had people from representing patient advocacy foundations, not-for-profit users of and developers of pharmacoeconomic evaluations and representatives from pharma, industry, insurers, and so there's a lot of people to be acknowledged and groups to be acknowledged. So just for context, cost effectiveness analysis, as you may know, has historically not been front and center in terms of national priorities for funding, largely because there's been a lot of issues with the idea of rationing resources, and then it was extrapolated to death panels some years ago because we are limiting the ability for patients to have access to health care. So that's been a major reason why we haven't seen much in the way of cost involved in decision making. But we have seen progress in the way of patients being involved in decision making, which historically if you look at measures that were developed over the long term, there wasn't that much patient voice integrated into decision making, especially clinical decision making. And so with the Affordable Care Act, there was a distinct place carved out for patient-centered outcomes. And in fact, the triple aim of healthcare is, and this is according to how Don Berwick proposed, we want to focus on better health outcomes, better experience of care, and balancing how we achieve that at an affordable level. We have limited resources, so how do we balance cost, experience of care, and improving health outcomes? The only way to do that is to understand what those health outcomes are and measure them, understand the patient experience and measure it. This is the whole basis for patient-reported outcomes. There's also, obviously clinical outcomes, survival, ways of measuring mortality and morbidity that are not patient-reported, but these are all inputs into the patient, the population health measures. So the EQ5D has a role in being able to measure health. It also helps to establish value in a lot of ways. If you can measure health, you can help to inform and value it. You can inform economic evaluations. You can inform individualized decision making. If you have a standardized measure, it facilitates international comparisons of health on a population-based level, or even interpreting a metric on a scale that is interpretable. It can be used as an endpoint for clinical trials and to inform patients about how their health might be relative to the average person, so norm-based interpretations, and ultimately to inform policy and guide it, especially with respect to balancing that triple aim. ICER, which has emerged, is a fairly influential organization. In fact, we at UIC we have a group that's doing evaluations for ICER, led by Dan Touchette here, and one of their major metrics that are used to compare treatments is cost per quality adjusted life year, and that's also the metric recommended to measure health effects by the second panel for cost effectiveness in healthcare and medicine, and that the reference case is recommended at the societal level, which means that you need a value set to measure health that's not based on the patient perspective, but on the societal perspective. It's a population level perspective. And when if you saw Dr. Touchette's presentation last year, he spoke a bit about value frameworks. Here's a few of them, and you can see that they tend to take a payer perspective or a non-payer perspective, and if it's a payer perspective, it's pretty consistent. Cost per quality is recommended as the primary measure of value. So how do we come up with these this quality, or how are qualities calculated? Extremely basic. It's how long are you in a health state for, and what's the value assigned to that health state, and then you can, one of the assumptions of the quality model is that these are proportionally related, linearly related, and you just multiply the two, quality by quantity of life, and then you compare different scenarios, say treatment exposure to drug A versus B. And then from a population perspective, it can help to inform the selection of treatments. So what is the EQ5D? For those of you unfamiliar, 5 dimensions of health. And it's described as a generic measure, which is to say that these 5 dimensions are generally relevant to everyone in terms of what matters as it relates to their health-related quality of life. There's some disease states in which there's other dimensions that are important, but that's where the role of disease-specific instruments come in. And often, a lot of health technology assessment groups recommend the use of both a generic and a disease-specific measure as endpoints in evaluating treatments, so that you don't miss disease-specific changes, but the generic measures facilitate comparison across the continuum of the healthcare sector. So there's a 3-level version, and then there's a 5-level version of this measure. Now, why are there 2? And I shouldn't say that they're versions. They're totally different measures, technically, but they are modeled upon the same dimensions, very slight differences. And obviously with 5 levels, if you were to have the same extremes in terms of your best and worst health state described by each dimension, it's sort of like having 3 steps on your pyramid versus 5 steps to get to the top of this pyramid of the same height, if there really is the same distance between the 2 extremes. So therefore, you're going to be able to have greater ability to discriminate levels of health among people who are responding to the 5L compared to the 3L. And also because these intermediate levels here, slight problems and severe problems, generally the middle category calibrates pretty close to the middle category on the 5 level. Therefore, these intermediate categories here, slight problems and severe problems, allow for more steps, which should lead to reduced ceiling effects, greater discriminatory power, and improved descriptive richness. And that's been supported by a number of studies. So the descriptive system, it had been in development for about 5 years, and it was published in 2011. But the descriptive system is not enough to have a value using such a measure. You need to have a value set as well. That's the second stage to development of a multi-attribute utility measure or a preference-based measure. And so a mapping function was developed between to link the 2 descriptive systems such that you could calculate a preference-based score in the absence of a value set, linking back to the original 3-level value sets that were published previous to the 5-level emerging. I could do a whole presentation on just the development of the protocol or the intriguing things that have happened over the years. There's interesting issues that arise in the UK, for instance. There's been many discussions and symposia trying to figure out the transition between the 3L and the 5L in the UK, because the National Institute for Clinical, is it Excellence? Yeah. Excellence? Is confronted by the issue of if these measures actually generate different qualities, because of course you got a different measure, a different value set, it's going to generate different qualities. If it generated identical qualities, then there would be no need for a 5L. So now it changed the kinds of cost effectiveness thresholds that are generated, and there can be potential for gaming by industry or to select whether they use the 3L or the 5L, but there's also kind of a structural difference in the kind of quality estimates. So NICE has to decide, well, do we change our cost effectiveness thresholds for adopting a new healthcare technology? Those are some issues that are secondary to introducing a new instrument and then having a wholesale movement to that being the recommended kind of gold standard, which the EQ5D is in the UK, in the sense that NICE supports the decisions that ultimately are adopted by the National Health Service in the UK. Most of the ICER evaluations seem to use, although there's no specific guidance on the EQ5D use, and correct me if I'm wrong, Dan, but are most of the evaluations using the EQ5D as a basis for the qualities that, yeah, for ICER?
I actually can't answer that. For the models that we've developed, we've not had the opportunity to use EQ5D because there weren't values available.
Mm-hmm.
They're rare conditions.
Right, and that's one of the challenges that just cost effectiveness in general, in early adoption of technology at least, there's just not the evidence available.
In the migraine model, we got utility estimates that were from the EQ5D.
And that tends to be what is available, right? Yeah. Because it's so widely used, to whatever extent it is imperfect, there's a lot of literature. I think something like at least 70% of all literature on utilities is based on the EQ5D. There's a lot of instruments out there, but the EQ5D is the 800-pound gorilla in the room. So, in transitioning, or the UIC group developed a scientific strategy such that there was a desire to do some experimentation with valuation methods, but also to try to improve upon some standardization such that the value sets were more comparable, because there's so many things that you could do differently depending on your level of informativeness and also your preferences for certain, say, elicitation techniques. So if you've taken, I don't know, pharmacoeconomics or the drug policy reimbursement class, does it still teach like direct utility elicitation, like TTO and standard gamble?
Yes.
It does? Okay. So those are some choices that you might have before you. There's TTO, there's standard gamble. Is necessary to refine these models, necessary to refine that protocol. So there was a pilot testing phase. The U.S. was involved in that, and then a standardized protocol was developed, and there continues to be improvements. I was concerned about doing a U.S. study, considering the size of the country and the expense of developing a value set early on, because I knew that there was going to be some issues that could possibly be better worked out, and in fact, some of the studies were halted for a while in order to iron out some issues. One of the issues was that if you use different interviewers, there could be an interviewer effect. And so that was one of the things that was a very important teachable moment for us. So I now want to talk a bit about the details around the U.S. study and then present you with some results. We used the same interviewers, as I mentioned. We had a multi-pronged approach to recruiting participants using some different strategies, online forms, in-person recruitment when we went to different locations around the country, going to local contacts and communities, but also this researchmatch.org, which is a resource that you can think about if you're thinking about doing a study, where people register to make themselves available to research opportunities, and then you reach out to them indirectly, and they decide whether or not they're going to allow you to further contact them. We, based on the understanding of previous country-specific evaluation studies. We had a target of 1,000 respondents, and basically it was U.S. residents, adults, that could understand what we were doing. We used a quota-based sampling approach based on age, gender, race, ethnicity, and we focused on recruiting from all 4 U.S. Census regions and 6 major metropolitan areas nested within those 4 regions. There are some limitations in terms of generalizability, but it was a balance of what we could do with the resources we had available. There is a standardized software platform that all the interviewers were trained in terms of using. It's called the EQVT. There's publications on it. Again, it reduces or it improves data quality because there's a very standardized approach, and there's benchmarks that have been developed by the scientific staff in Rotterdam that helps to coordinate all these evaluation studies around the world. I don't think I have a slide on the different studies, but there's a lot of value sets. There's 10 of them. For the 5L has almost every country in Asia. There's, for instance, Ethiopia just completed their study. They're all over the world. Saudi Arabia's had a pilot. So the U.S. is very much. I don't want to say we were a laggard, but we definitely are long awaited in terms of getting this value set out there. I'm not going to go into a great deal of detail on the design behind the choices around the elicitation tasks, but there was quality control. We had versions available to be administered both in English and Spanish, and we had 2 of our interview team were fluent in Spanish, as Ashley and Jonathan. The tasks were presented in the same basic order, so they weren't randomized, but there was some important learning that was included at different phases. For instance, the respondents became familiar with the health states and how they are framed, the wording of them, through the time trade-off, and then it expedited the discrete choice experiment tasks. I'll show you what these look like, and how many of you actually participated in this? Who gave? Okay, so first of all, thank you very much, and so I should almost ask Dr. Lee to explain this to see if you could remember how to do it. But this is an illustration of how the time trade-off was presented, and the basic premise is you're asked if you are indifferent to option A or B, or if you'd prefer scenario A or B. A is 10 years in full health, then die, versus a suboptimal health state. And this is let's say a health state vector or profile of the 5 different domains and different levels within each domain. So this would be 2, 1, 1, 1, which is slight problems. 1 is no problems. So you can see it's just a slightly suboptimal health state where you have problems walking and slight pain and discomfort. The question is, would you be willing to give up any life years over the course of 10 years in full health, or do you feel that you wouldn't be willing to give up any life years? And if not, then you'd feel they're about the same. And if you'd say, oh, I definitely prefer 10 years in full health, then you would have this ping pong technique where another option would become available to you. In this case, this is another illustration. You now have a different scenario where this is how we elicited your willingness to trade off time if you considered a health state worse than dead. I think in the interest of time, I am not going to explain all the details here. The tutorial actually often took like 10 minutes for us to explain this to the respondents. It's much easier to present a DCE. It's a pairwise comparison. We simply ask you which health state you prefer. So there was 7 of these presented. There was 10 scenarios, time trade-off scenarios presented to each respondent. So we have multiple observations per respondent. So there's dependency in this data, right? And so for 1,000 respondents, we would have 10 time trade-offs per respondent, which would be upwards of 10,000 observations that we could use to estimate a value set based on the time trade-off. Discrete choice experiment, this information is a form of ranking. The nature of the data is slightly different. So here's a comparison and contrast between the 2 elicitation techniques that were used. And that will be available to you in the publication if you're really interested. There's some technical details there. So I'm just going to show you a brief video that shows you the data collection experience. And how do I get out of this? Do I just exit? Yeah. And I just quickly want to play you this
Make it full screen.
teaser here. So this is the research team, and this is the team in action. This is really what the experience of the data collection was and how we went about doing it. You guys recognize anyone in these videos? What city was that? Oh, no. There you go. So that was just an example of the kind of work that went into it and the travel involved, and what a fantastic research group we had, and this study wouldn't have been possible without everyone's dedication, and I really think that it wouldn't have succeeded without the input. Actually, Rayshawn and Ernest did just an awesome job of helping to manage the projects, and then they interviewed different students and made sure that they were a great fit for the kinds of qualities that you need in working as a team and people staying at hotels with each other. and traveling and doing it on a very marginal budget. So it's great to get to this stage. So now we're getting into the statistical modeling, which has been a whole adventure unto itself, and I'll tell you one reason why. We actually had expedited review in medical decision making for this paper, and one of the issues raised by one of the reviewers was the dependency of the data. Now, we used a similar statistical modeling approach to other groups that have published on their value sets, but they did not take into account the dependency of the data. And sometimes it's important, sometimes it isn't. But when we talk about dependency of the data, how could you address that? What are some statistical modeling techniques that take that into account? Anyone want to point out ways to? Random effects, for instance. So you have a respondent level random effect built into it. You can, in fact, have a random effect associated with each attribute, and not only each attribute, but each level within each attribute. And so if you really want to go crazy on a model, you can try to estimate. So what does a respondent level random effect do? It takes into account whether or not there are systematic differences in how harshly someone, or how willing people are to trade, say, time across the different health states. So someone systematically might have higher values, others might systematically have assigned lower values to health. That's what a respondent level random effect would do. But you could also further partition that in terms of, okay, well, maybe they value depression systematically different than pain and discomfort. And then they're the same as everyone else for mobility, self-care. So we decided to go the extra distance and try to incorporate random effects. And we did that not just for this Tobit model. So these TTO values, you have to model them differently than choice-based values. And typically a conditional logit is applied. You can also do a mixed logit, which is a more advanced approach that will take into account individual differences as well. And then you've got a hybrid model in which you could also try to incorporate random effects. Well, we worked with an international expert on this, Eleanor Polinigam. She's a Cambridge-trained mathematician. She's a professor at University of Toronto, and we've worked on it for the past 4 months. Yeah, probably 4 months, 5 months. The models we had hosted on the PSOP server, some of them took 178 hours?
17 days.
17 days, sorry, 17. This is how long some of these models would take, and then they wouldn't even ultimately converge. So we gave up on estimating random effects for the hybrid model, and we focused on refining the models for the TTO data and the DCE. The basic specification, in addition to the estimators, was a standard additive model, 20 dummies, which is, you got 5 dimensions, 4 levels for each dimension. Here's a compare and contrast. If anyone has questions about how we specifically approached the estimation, I'm using this as a reference slide. Some of the details that are relevant is that the Tobit model used censoring at -1 because, in theory at least, although we truncated the values at -1, or we stopped the ability for them to go lower than -1, this censoring approach allows the estimation to go lower than -1. And then we also modeled the error variance around each health state differs. So that heteroscedasticity can be addressed or not in your model, and we ultimately modeled that using a quartic polynomial. As you can see, there's 1, 2, 3, 4, 5 in there.
Yeah, the quartic is to the fourth power.
Fourth power, right. So we were debating, why shouldn't that be like quintic or something? Anyway, it was a lesson in polynomials, learning about that. So why might you want to use this hybrid model? Well, some countries have used it, combining that data that was obtained both from the TTO and the DCE. And so there's arguments for and against the idea of combining it. But the nature of the data is different. The nature of the task is different. In some respects, it gives the best of both worlds in terms of you're maximizing the information that you have on preferences. A statistician or and a psychologist might have arguments against it. Like a psychologist, you're asking it's a different task. Which do you prefer versus trading off time and in health states are two different things. And our DCE did not include duration. So the fundamental task where time is being traded off for the TTO is not integrated into the DCE exercise. There's also not an opt-out option for DCE, which would be necessary in order to make it comparable to the TTO task. Because in TTO, you can choose not to trade, whereas with the DCE, you're always forcing someone to choose between the two options. Therefore, we, to some extent, we explored both, and we also had so those are some theoretical considerations. The idea of having a parsimonious model was also a consideration. Logical consistency of the parameters. So are they monotonically ordered in terms of the parametric estimates? So is a more severe health state, does it have a greater disutility or a larger negative weight assigned to it? And then is there a statistical significance in the difference between the different levels? So those were all considerations. So the results, we didn't have a lot of people that failed to complete the interview. It was less than 10%. Ultimately, those were the people that we retained. And you can see that remaining observations after feedback module. This feedback module was an ability after the time trade-off exercise for the respondents to reflect on their responses and go, and if there was disordering, for instance, it was brought to their attention, and they could decide, like for instance, a dominated health state, and they could decide if they wanted to retain those responses or if they wanted to revisit them. And so it's a form of sensitivity analysis. I know you guys have to leave. Thanks for the heads up. And so we removed about 10% of the observations based on that feedback module. How good were we at this quota-based sampling? Well, our results were indicated that very comparable to the 2015 census data across the criteria that we had based our quotas on, but also the characteristics of the respondents that were not quota-based. Pretty comparable educational level, even pretty comparable level of self-reported chronic conditions, which was pretty impressive. This is our study sample compared to what is estimated for the general population. So we felt that we had a pretty good representation of the general population. This is one way to try to just eyeball whether or not your responses are as you would expect them to be. This misery score is simply a simple summary score that can be obtained across the profile. So a misery score of if you responded no problems, slight problems for this dimension, moderate problems for this dimension, you'd end up adding them together, getting a score of 15. And of course, 5, 5, 5, 5, 5 would be a misery score of 25. And as you would anticipate, you should have a lower mean utility score as the health state, as simply described by the misery score, gets worse. And so this is exactly what we'd have expected. And in addition, you'd expect the standard deviations to go up, the variance. And in part, it's also because the number of health states with this kind of misery score was smaller. Therefore, you'd expect more variance around it. Okay, this is what the observed TTO responses look like across all of the data. So these are non-traders in terms of health states where respondents chose not to trade any years of life. That's about 22% of all observations. And then you can see also that about 20% of all observations were valued at worse than negative 0.5 or lower. And 15% of all health states were assigned a value of -1. So people were willing to not just choose to die, but also to give up an additional 10 years of life in order to avoid that health state because it sounded so horrible. Okay, so relative to other countries that had done these types of studies, the face validity of these responses looked good, and we were quite happy with it. And also the DCE responses, this is a way to just eyeball the face validity, where this is the difference in misery scores between two health states were being presented. And as you might anticipate, if there's no difference in the misery score, you'd expect around a 50-50, all other things being equal, kind of likelihood of someone choosing health state A versus B. But it shouldn't be perfect because different relative weights are assigned to different dimensions, so we wouldn't expect it to be exact. In fact, these studies are designed in a way to try to maximize the amount of information based on the health states you present. Did I go backwards? Yes, I did go backwards.
Wait, sorry, I think that's a repeat slide.
Oh, okay, so these are the actual models. And there was some slight disordering of the DCE. It had to be rescaled to the TTO because DCE is a latent scale. It doesn't actually, it's not anchored on 0 and 1, where 0 is dead. You have to actually include dead in the DCE, or there's a number of other options, but we didn't have duration. So we anchored it against the time trade-off scale. And then we combined the data. Now, when we used the hybrid model, it actually gave us, across all of the dimensions and attributes, monotonically ordered coefficients. The TTO did as well, except for usual activities, level 4, which was severe problems with usual activities and unable to do usual activities. They weren't statistically significantly different from each other, so we constrained the estimate such that it was the same, and otherwise, so basically we're saying that these two levels have the same disutility. So on the balance, we had to decide: do we want to go with the TTO TOBIT or the hybrid model? Their characteristics, for most intents and purposes, were fairly similar, except the state 55555 was really quite low, almost minus 0.7, and that was driven by a number of factors. including the heteroscedasticity and how the treatment of the of -1 in the censoring, and we had to spend some time exploring how to best model the heteroscedasticity and see if we could address this additional drop in the porous health state 55555. Otherwise, they're pretty similar, and ultimately we felt most comfortable going with the Tobit model. For one, it doesn't have to invoke that additional assumption that DCE and TTO data are appropriately combined. And we actually, I have a paper coming out with Eleanor and Feng. You guys met Feng last year for Ernest's dissertation defense. He was Ernest's external examiner, and we found that the actual underlying preferences, if you analyze how people cluster together in terms of their preferences, the grouping is slightly different for if you cluster people based on their DCE preferences compared to their TTO preferences. We didn't get to the point where we've done that with this data, but that was done with the data from 6 different countries. So that's a strong part of the rationale for the selection of the TTO Tobit model. And if you want to know how it compares to the range of scale that has been used for the US 3-level version that was published by Shaw in 2005. Some of you might remember Jim Shaw, who's a faculty member here. That paper has been cited at least 1,000 times and probably used 1,000 times more. That range of scale is, it ends at about minus 0.109 is the value of the worst health state. The value for the worst health state for the 5-level, as you can see, is more like minus 0.55. So it is, it has a greater range of scale, and it'll be interesting to see some research that applies the algorithm and sees how the cost per quality are compare using the 3L versus the US 5L value set. So just to illustrate how you do this health state utility calculation, if you were to get, participants in a clinical trial or otherwise to complete the EQ5D 5L, they then check off their health state profile, how they describe their own health. Then the researcher, the project coordinator, applies a scoring algorithm, and you get their single summary score, which represents their health state utility. So let's take, for instance, the health, someone that responds that their health is 1, 2, 3, 4, 5. No problems in walking about, slight problems dressing or washing, moderate problems with usual activities, severe pain or discomfort, and extreme anxiety or depression. We take the coefficient, each one is subtracted from full health, and there you get the utility value for this health state, which is 0.171. Okay, so that's how you apply the value set. I'm going to stop there. I think I've pointed out all these major conclusions, and ultimately we'll see if this is used by the scientific community as a value set that will help to inform economic evaluations. Thank you for your time.